Hello everyone, and welcome to today's Dynamics 365 Tech Talk in the Store Commerce Migration series. Today's topic is Dynamics 365 Commerce, Best Practices and Patterns. My name is Tim, and I will be your moderator today. We are broadcasting this session through Teams Live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you are agreeing to this experience. The recording will be made available on the TechTalks Community Dynamics page within the coming weeks. If you have questions for presenters or need support, please use the Q&A panel located at the right side of your screen. The presenters will be responding to your questions throughout the session and in a live segment after the presentation. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Srinath Sundaresan, Senior R&D Solution Architect, Vetri Chandranath, Senior Solution Architect, and Rob Bertram, Principal R&D Solutions Architect. Srinath, over to you to get us started.
Thanks, Tim. Hello and welcome, everyone. This is the third Tech Talk in a series of Tech Talks on migrating to the Store Commerce app. I am Srinath Sundaresan, and I am joined by my colleague Vetri Chandranath and Rob Bertram. Whether you are watching us live or on a recording, we thank you for including us in your migration journey. Before starting the Tech Talk, here is a slide on the implementation guide for Dynamics 365. If you have not already seen this, we recommend you to go through the implementation guide. This is a must read for any Dynamics 365 implementation. I encourage you to read the guide as there are many repeatable patterns that we reference in this series. As I mentioned, this is a three-part series with two parts already broadcasted on 29 November and 1st December. You will be able to watch the recordings online in the Dynamics community page. The objective of this Tech Talk is to take you through the high-level steps for converting existing point-of-sale extensions to the independent packaging model. We will take you through common patterns in the code migration, and we'll also talk about best practices in the code migration process. The independent packaging model in the SDK provides an updated and improved developer experience for the development of Microsoft Dynamics 365 Commerce extensions. The independent packaging model creates more separation between the SDK and the extension that is being developed. The SDK consists of a set of NuGet packages. These packages contain artifacts that enable commerce development. Because of the scope of the changes in the independent packaging model, a few changes are required. Conversion of customization so that they use the independent packaging model requires a code migration that takes slightly more than a standard version update. What we don't cover in this Tech Talk are installation and configuration, migration, strategy, timelines, etc. For information related to these topics, you can refer to the recordings of the previous Tech Talks in the Store Commerce Migration series. If you are a person who has done a bit of Dynamics 365 Commerce development, you will feel at home when we talk about some of the technical details and patterns associated with the Store Commerce migration. Here is the agenda for today. We start by talking about the POS extension and the SDK changes. We will look at some of the patterns to be used in the code migration for the POS extensions. We will call out must-dos from the code perspective to migrate to the independent packaging model. We will then move to the steps and patterns in the migrating the CRT extensions. Then we will cover the changes in the localization and talk about how we are working towards adoption of localization changes easier and faster. Then we will be given an overview of application insights and obsolete features. In the Commerce SDK, we kept all the best aspects of the POS extensibility framework intact. This means most of the POS extension APIs and concepts are unchanged from the Retail SDK, and a very few code changes will be needed to migrate to the Commerce SDK. With that in mind, I'll start with a brief refresher on what type of extensions are supported in POS. So there are different ways to extend the Dynamics 365 Store Commerce app. The app can be extended independently by using the extension feature of the SDK. You can modify and create the new user experience, enhance or modify out-of-the-box functionality, add validations, and add custom features and new functionality. You can do extensions in the following ways: extend the POS user interface. You can add custom columns, app bar buttons, custom controls depending on the view. Override business POS business logic by overriding the POS request handlers. You can extend POS business logic to add custom logic, add pre-triggers, post-triggers. You can add custom logic before and after any POS operation, consume new APIs, POS exposes APIs and user experience controls that can be consumed in extension scenarios. You can extend POS to add custom views and new APIs that support new functionality and features. And you can also add custom operations to perform custom functionality. So the POS APIs help you to easily build extensions or new features to the POS app. For example, if you are extending the application to add new features in which you want to get product details, change prices, or add items to the cart, you can consume APIs that will do the work for you. The POS API simplifies the extension pattern and provides continuous support to build the extensions. Extensions patterns have unified across CRT, POS, and hardware station by following the request or response pattern. All the POS APIs are exposed as request responses like the CRT and hardware station. The POS API library contains a set of modules that are organized based on the way that the extensions will use them. So the extend module, these module will help extensions extend POS components and workflows. The subdirectories are organized first by type of the component, and that will be extended, and then by the feature area that will be extended. Examples are like POS API extend views or POS API extend triggers. And then there is a create set of modules. So these modules help extensions create new components and functionality. Subdirectories are organized by the type of component that will be created. An example is like POS API create views. Then we have the consume. Consume public APIs. We can consume public APIs in your extension. For example, the new controls. For a complete list of APIs and the type declaration for the modules in the POS API library, you can see the pos.api.d.ts file that is distributed together with the Microsoft Dynamics Commerce SDK POS and get package. There has been some key changes in the SDK. First one is the removal of the POS UI SDK library. We have removed the reference to POS UI SDK library, which was dependent on Knockout.js. When you develop an extension, you can choose which user interface library you want to use. At the same time, you can maintain a consistent look and feel throughout the application. One of the biggest changes to the POS API in the sealed extensibility model was the removal of all references to Knockout.js in POS contracts. The POS UI SDK library has been replaced with consume APIs for POS controls. You can find these APIs under POS API consume controls. The knockout.d.ts file has been removed from the SDK. Therefore, the global co-variable isn't available to extensions. We have a demo later on how to use Knockout or any third-party libraries. To make the process of creating extension views more maintainable and intuitive, we have replaced the extension view controller base class with a new base class for custom views, custom view controller base. The main difference between the new custom view controller base class and the extension view controller base class is that when the independent packaging model is used, the header and navigation bars are automatically shown. If you used extension packages that are independently distributed and serviced, POS relied on a single extension.json file to list all the extension packages that had to be loaded. However, that approach was incompatible with the independent packaging model. So in the independent packaging model, POS calls the headless commerce engine to get the list of packages, extension packages that needs to be loaded. Another important change is in the extension packaging. We will now be able to generate multiple extension installers for the extension functionality. It is not possible to use the POS UI SDK library in the extension solutions. You will need to migrate any references to the POS UI SDK library. We now have a different way to use the POS controls in extensions. In your extension, you should do a global search for the POS UI SDK. For each reference to POS UI SDK, replace the use of the POS UI SDK control with the approach that uses POS controls from the POS API consume controls. The POS API library provides a consistent look and feel between the extension user interface and the rest of the POS by giving access to common POS controls. These controls are available as interfaces in the POS API consume controls module. Instances of these controls can be created by using the control factory that is provided in the extension context. The UI extension classes include views, dialog boxes, and custom controls. The new POS controls are shown on the slide. We also have new interfaces to work with these controls like iData list, iAlpha, numeric numpad, etc. So there are some changes in the manifest schema, and each extension solution should refer to a manifest.json file. The manifest file contains important information about the extension package and defines a list of extensions in the package. The manifest file must follow the manifest schema that is provided in the microsoft.dynamics.commerce.sdk.pos.NuGet package. Otherwise, POS can load the extensions. There are a few fields in the manifest schema which are important. The minimum POS version that is required to run the extension package. The version number depends on the POS NuGet package that you are consuming and the POS app that is installed. For example, the extension project should not use POS APIs or extension artifacts from a version that is later than the version of the POS app that is installed. At runtime, the POS app checks the version of the extension package. If it's later than the version of the installed POS app, the extension package won't be loaded. Supported country regions is another such field. The optional list it has the optional list of country region codes to load the extension package in. If no value is specified for this field, the extension package will be loaded regardless of the current POS country or region. Last but not least, the name is the name of the extension package. It is not possible to make changes in the out-of-the-box POS API library. You can only refer to existing interfaces in the POS API. You can find more details about the interfaces and types in the pos.api.d.ts file. So no modifications are allowed on the pos.api.d.ts file, and extensions must consume only exposed requests and responses in the file. POS loads a list of configured extension package definitions from the headless commerce engine by calling the get extension package definitions API. The get extension package definitions API runs the get extension package definitions CRT request. To configure POS to load your extension package, add a CRT trigger for the request and add your extension package definition to the list of definitions in the response. The fields in the extension package definition must match the values that were used when the POS extension package was created. So some of the fields are named. So the name is used to find and load the POS extension package. Therefore, it must exactly match the package name value for the extension package project. The publisher must match the publisher that is specified in the extension package manifest.json file. The last topic to discuss before we jump into the first scenario and demo is the Store Commerce extension installer package. The Store Commerce extension installer package is a .NET Core console application. The console application generates the exe file for the installer. The CS proj file for the console application should have a reference to the public feed package, the dynamics.commerce.stk installer.storecommerce. Also, there should be a reference to other component projects in the solution like commerce runtime, channel database, etc. So after building the project, the exe file can be found in the bin folder. You can use the install command on the exe to install the extensions. Here is the first scenario for today. We will look at the steps for migrating an existing POS extension to the independent packaging model. We will discuss the common migration patterns in the demo.
In this demo, we will look at steps for converting existing point of sale extension to the independent packaging model. For this, we are going to pick some Retail SDK sample extensions from the Retail SDK folder, and we are going to migrate these Retail SDK extensions to the independent packaging model. The sample extension we have picked is the barcode MSR dialog sample. So you can find the sample extensions under Retail SDK, POS folder, extension, sample extensions, controls, and then you can see the barcode MSR dialog files. So inside that folder, you can see the dialog HTML file, the dialog TS file, MSR dialog TS file, the barcode MSR dialog types .ts. In addition to these files, I have also picked up a few more files which are required for this extension, like the helper.ts file and the fulfillment line command file. So I have placed all these files under the barcode MSR dialog sample old folder. So why we have picked these this specific sample because is the sample is using knockout and also is using POS UI SDK control. Using this sample, we can look at some of the patterns in migrating the existing POS extensions to the store commerce app independent packaging model. Let's dig deeper into the existing code. So as you can see that this sample has a reference to the POS UI SDK control. It's using the numpad control from the POS UI SDK. And also it has a reference to the knockout co variable, and it's being used also in the sample. So the code is a templated dialog used for barcode scanning. So you can see the class is a barcode MSR dialog, and it inherits from the extension template dialog base. Now let's take a look at the MSR dialog.html file. So you will in the HTML file you will see the data bind, the knockout data binding, and you will see the binding handler for MS POS alpha numeric numpad being set. And there are some other files like the dialog types, fulfillment line command helper.ts. These are some of the helper files or the type files, as well as the command to open the dialog. And I have also copied the manifest file from the Retail SDK sample extensions folder for side-by-side comparison. You can see the barcode MSR dialog HTML and the barcode MSR dialog.ts HTML path and as well as module path inside the manifest.json file. Once we have identified all the files that needs to be migrated, the next step is to create a solution. In the workspace, I have created a folder called barcode MSR dialog sample, and I have copied the files into the POS folder. These files can be seen like barcode MSR dialog.ts, barcode MSR dialog.html. And what I have also done is I have added the manifest.json file in the solution, the extension solution. So I have named this barcode MSR dialog sample, and I have copied over the HTML path and module path from the manifest JSON, the Retail SDK manifest JSON to the manifest JSON in the extension solution. So I have marked this as a templated dialog, which is new templated dialog, and its name is barcode MSR dialog. The HTML path is barcode MSR dialog.html and barcode MSR dialog .ts for the module path. So I have also added a command for opening the dialog. So this will be available at the fulfillment in the fulfillment view. Now we will need to do some code changes to convert the barcode MSR dialog.ts into the independent packaging model. The first change is to use the POS API consume controls instead of the POS SDK, the numpad control. So I have changed the reference to POS API consume controls, and I am using now the alphanumeric numpad and the alphanumeric numpad options. You will also notice that I have removed any reference to the knockout from this code, and now I am going to use the out of the box POS API alphanumeric numpad control in the templated dialog. So for that, I have changed the numpad to the alphanumeric numpad, and I'm now going to instantiate that numpad. We are going to create an instance of the numpad by using the control factory in the extension context, and now we are going to pass the following values like the numpad options as well as the numpad root element, where we are going to place the element, the HTML element where we are going to place the numpad. So the HTML element is the barcode MSR dialog alphanumeric numpad HTML element. We can look at that in the HTML. So I have changed the data binding, and I have just I'm just using the ID here for the barcode MSR dialog alphanumeric numpad. We are going to be placing the numpad in this HTML element, and going back to the TS file. Now, once we have the numpad is instance created, the control created, we can also add new event listeners to the numpad for value changed or enter pressed. Some of the events that were earlier there, that we are able to add event listeners similarly to the previous one. So we looked at the two patterns. The first pattern is removing the dependency on the knockout by using the new POS controls for the alphanumeric numpad, and also by the removing the dependency on knockout, we are also using the POS API consume controls instead of the POS UI SDK controls. The POS API consume controls module contains interfaces for POS controls that provide the same functionality as the POS UI SDK without the dependency on Knockout.js. So removing this dependency on Knockout.js will allow the POS controls to evolve and modernize over time without any breaking changes to the extensions. The biggest difference in the new controls is how they handle UI updates through events instead of observables. Now let's take a look at loading the migrated POS extensions. Earlier, we used to have an extensions.js file, which had to be modified to load these extensions. With the independent packaging model, there's a change in that pattern, and now the POS calls the Commerce headless engine to get the list of POS extension packages that needs to be loaded. So as part of this pattern, we are going to create a new trigger in the Commerce runtime. It's called a define POS extension package trigger. So this trigger is for the get extension package definition request, and on executed we have to add these additional extended package definitions. in the response. So here we are adding the countersort.barcode MSR dialog sample package definition in the response. So after this is done, the POS will call the headless commerce engine to get the list of POS extensions that needs to be loaded. Let's now go into the store commerce app and see if the extensions have loaded correctly. So let's go to the barcode MSR dialog sample, and we can see that the templated dialog and the command has been loaded correctly. To test the functionality of the extension, so we can go to the home and we can go to the fulfillment order fulfillment, the fulfillment view, and we can see the new command here for scan and select product, and after clicking this we are able to see the barcode, the dialog. So we looked at migrating a sample extension, existing sample extension to the independent packaging model. We also looked at using the new consume POS API consume control. So we also looked at removing the knockout dependency from the extensions. We also looked at how to load the POS extensions by creating the defined POS extension trigger in the commerce runtime. We also validated that the extensions have loaded and the functionality is working correctly.
External applications can use the proxy to interact with the Commerce APIs. The Commerce proxy abstracts the Commerce APIs and the Commerce runtime entities request and response, and generates interface or metadata for the external application to consume. For example, to consume the custom entities in the Commerce API in the external applications, either you can use the metadata generated by the proxy tool or manually create all the entities and request response metadata in the client applications. And this manual creation involves a lot of additional overhead because you may need to maintain update and duplicate the entities manager request response code. In the earlier versions of the Retail SDK, generation of the TypeScript proxy had to be done manually to consume headless commerce APIs in POS. In the independent packaging model, the TypeScript code for data service requests and entities is now automatically generated. Therefore, the process is simpler. Because the TypeScript proxy for POS is automatically generated when you build your POS extension project, you don't have to manually run the commerce proxy generator and copy the files. In the next scenario, we'll see how to consume CSU APIs in POS. In the demo, we will be creating a new custom API, and we'll go through the steps of automatic proxy generation and consuming the APIs in the POS extension.
In this demo, we will look at how to consume custom headless commerce APIs in POS. POS uses the TypeScript proxy to access the commerce APIs and CRT entities. In earlier versions of the Retail SDK, generation of the TypeScript proxy had to be done manually to consume headless commerce APIs in POS. In the independent packaging model, the TypeScript code for the data service requests and entities is now automatically generated. We are going to look at a scenario where we are going to consume the custom headless commerce APIs from POS. The POS project will automatically generate the proxies based on the Commerce API project referenced. To create the custom API, we are going to use the scale unit sample. We are going to get the code inside the Commerce runtime, which has two controllers. One is the bound controller and unbound controller. And we have entities, messages, request handlers, and triggers already defined in the scale unit sample, and we are going to use that in our workspace. I have moved all the files from the scale unit sample into my workspace, which has the bound controller and bound controller, example entity, the messages, request handlers, etc. So the bound controller is bound to the example entity, and it exposes a bunch of operations for get all example entities, create example entity, update example entity, And similarly, unbound controller has its bunch of also operations exposed. All these files are added to the Commerce runtime project. In the Commerce runtime project, there should be a reference included to Microsoft.dynamics.commerce.sdk.runtime. Now let's take a look at the POS project, which is going to consume the custom API. So you can see that in this POS project, there is a reference required to the Microsoft.dynamics.commerce.sdk.pos package, and this POS project should also reference the Commerce runtime project. After these changes, let's now go ahead and build the solution. The build is now complete. Let's now go to the POS folder, and you'll see that there is a new folder which has been created called data service, and this data service folder will have the data service request, the data service entities that are required in the POS view extensions, and these will have the data service requests as well as entities. Let's go ahead and verify. We can see our example entity. Yes, we can see that our example entity has indeed been added. And this example entity can now be added in the views or view extensions. We can also see that the build has generated the data service request.g.ts. Inside this, we can go and find our bound controller. Yeah, so we can see that the proxies has been generated successfully. Now we will see how we can use these proxies inside our views, view extensions, view models, etc. So now let's go to the example view.ts. We can see like how the data service entities are used. So we are using the example entity in code, and this is referencing the data service entities.g file that we created during the build, that was automatically generated during the build. And where we can also go to the example view module.ts. Also, this is referencing the data service request.g, and this is using the messages bound controller, the get all example entities request message. So we have seen how the proxies are automatically generated. Because the TypeScript proxy for the POS is automatically generated when you build your POS extension project, you don't have to manually run the Commerce proxy generator and copy the file. We have seen how to use proxy to consume custom headless Commerce APIs and entities in point of sale. Also, we saw how the data service entities and data service requests are auto-generated.
Now I will pass the control over to Vetri.
Thanks, Srinath. Okay, we'll jump on to the next pattern. Is it possible to use the knockout in our extensions now? And to get rid of the hard dependency on the knockout.js and also make the service more update simpler, in the sealed extensibility model, all references to knockout.js in the POS contract were removed. In a longer run, it will help avoid causing the breaking changes and to help evolve our product. This is what we made. You need to keep in mind that in your extensions, you cannot refer to the global instance anymore, but you can also refer to your local instance if you want. You can add your knockout.js explicitly in your project and make use of it. We'll see how to add a knockout.js and any third-party libraries in upcoming demo. For pass controls, you can find these APIs under pass API/consume/controls. How to use external libraries in your POS project. Now it is possible to add any third-party libraries and to the extensions. similar to the knockout library, what you add before, and consume the same. Just that there are additional steps that you need to follow to add the reference that we'll see in our demo. This will help using the functions and controls from your third-party library in the extension project, and also helps in independent packaging the solution. In such case of where you wanted to add the additional libraries, third-party libraries in your project, you need to make sure that you're adding the external libraries and also their dependent libraries in your project manifest and MS build target to copy the dependencies. In our demo next, we'll see how to add any third-party library. We'll start with the knockout.js and all the steps that involved to add to the project and how to consume it. Hi, in this demo, we will see how we can add any third-party libraries, including knockout.js, in your POS extension project and how to consume the same. To start with, you will have to get onto the POS extension project and manage get package and get the knockout.js. And find out the right version you want to install and install the same. Once you install, next step is to unload the project, see, and onto the project, get onto the config and say, here what we're going to do is we're going to add the MS build target to copy the knockout library to your project directory when a build happens and include in your package. So we have the template already available in the learn.max.com, which you can take it from there and just paste it over here. Save it, reload the project. And few more things that we need to do is to get onto the manifest JSON and add the dependency. This will help updating your package file. And this will include the knockout library as a dependency when a package is built. You will have to add a new entry for the knockout library in the dependency array. If you already have one, just let's say if you have any other dependency already added, just update that here. So I added the knockout library dependency. Then save it. And next step is get onto the ts config and update the file so that includes the path alias for the knockout.js. So I'll do this one like this. So now you see that the knockout.js library information is updated here, and this will help using the alias knockout in your project. So once it is done, save it. And another thing which you can do is download the knockout.ts.d.ts and upload that into the folder. So if you see, yeah, so you could see that I've uploaded the knockout.d.ts file in my POS extension. This you can download from the knockout.js website, and you can find this in the folder that they have. So this is how when you download a file, you will see inside that you will see the file here. Copy the file and paste it over here in your POS extension. Once all these steps completed, you can go ahead and build. And once it is built, you can go and check if the reference is copied over. Let's say the knockout file should be in your libraries. So this steps confirms that we have done the right stuff. And once it is done, similarly, you can also add any other third-party libraries in your project and use it. I did added the Lodash as another third-party library in one of my project, which includes Knockout.js and Lodash. And now this is my trigger project where you can see that the I could refer both. Like I can import Lodash and also Knockout library in my project in my CS file, and also I used the function from Lodash here, and I use the Knockout.js as you do before. So this is how you can implement your POS extension using any third-party libraries. Hope this helps you understand how to add any third-party library in your project and how to use the same. Next pattern. What has changed when I create a custom view? We have made some changes to the creation of extension views to make it more maintainable and intuitive. Going forward, to create any custom views, you should use a new base class called custom view controller base, because the extension view controller base class has been deprecated or it is replaced with a new one. The new class provides the same functionality, but in a more maintainable way for us. The main difference between these two classes, custom view controller base class and the extension view controller base class, is that when an independent package model is used, the header and navigation bars are automatically shown. That will ease your UI development. Therefore, the extension development experience is simplified. Another thing that you need to note is that the independent package model extension views that were derived from the extension view controller base aren't supported anymore, and that won't be loaded going forward. And so it is necessary for you to migrate your extensions to start using the custom view controller base. iController. If you are planning to create an extension using the asynchronous retail server controller, which you have to extend it from new controller class called iController. And you should not refer to the commerce controller async class anymore, which you used before. Retail server extension using the commerce controller async has been deprecated to provide more simplified extension model. In the Commerce SDK, an extension must use the packages from the public feed and extend the hardware station controller class by using the iController interface going forward. Another point to note down is that the retail server does not support loading both the iController and the commerce controller extensions. If you include, or if your extension includes both using the iController and also the commerce controller, your retail server load will fail. So extensions should either have the iController or the commerce controller sync. If you're planning to migrate all your retail server extensions to use iController extension. And to keep the consistency, it is recommended to use the iController from the NuGet package while extending. Seal services. Some of the packages that were available before in Retail SDK folder are not available anymore in the Commerce SDK NuGet feed. For example, you cannot find the runtime.localization service or the runtime.service or even the pricing engine package. These extensions need to be rewritten to not to reference those classes, as they were not supposed to be referenced in your project anymore. The CRT extension code should not refer to or use any of these CRT business class logic methods or handlers, such as classes from the runtime.workflow.services or data services. These classes are not backward compatible, which could break the extensions during the update or upgrade. Extension should use only the request and response and entity classes from the runtime.messages, runtime.framework, or data and the entities. Rob, over to you.
Thank you, Vetri. One really important framework improvement is the introduction of asynchronous methods. Long-running operations like RTS calls, database queries, and network requests block the execution thread. Now that support for asynchronous operation has been added to the Commerce runtime, you can use asynchronous versions of these requests. This introduces a significant performance improvement as async threads run in the background as the execution thread continues. All extensions that you develop should adopt the async framework. This also enables some fire and forget patterns that were not possible before. For example, this could be used for sending an email copy of a receipt. We don't need to wait for that email to be sent before we can return control back to the POS and continue your shopping experience. Another major innovation is around globalization. Tax regulation and fiscal integration requirements for retailers have rapidly evolved over the past few years. Many countries require POS devices to submit sales and returns information directly to the local tax authority through secure and encrypted channels. Additionally, these regulations change frequently, which makes it very difficult for a retailer to stay compliant. In the past, the only way for a retailer to stay compliant with local tax authority was to write complex business logic in the CRT, as well as extensions to the hardware station in order to adhere with these regional laws. The Globalization Studio addresses these challenges by providing the following two features: no-code or low-code globalization tools and services, as well as out-of-the-box multi-country localization content. And this specifically is Microsoft provided content and is continuously monitored and updated by Microsoft and can also be extended by customers and partners. With the Globalization Studio, we have significantly reduced the complexity of implementing store operations in hundreds of locales. Above is the list of countries that required heavy customization in order to stay compliant in the past. Moving to the Commerce SDK, which uses the Globalization Studio, helps retailers operate in multiple regions with minimal to no IT development impact. I will note that we are still transitioning some regions over to the Commerce SDK, so regions like India, Saudi Arabia, and Sweden are not yet supported, and you still have to use the Retail SDK pattern. But we are working on those now, and we will. We hope to have those regions enabled soon in Commerce SDK. Another major framework improvement is the introduction of operational insights. This exposes a large amount of telemetry to the customer, telemetry that was previously only available to Microsoft engineers. Operational insights is designed to give customers better visibility into their service health and business functionality by sending telemetry directly to a customer-owned application insights account. This allows your IT team to have near real-time information about your commerce infrastructure, including the CSUs and point-of-sale devices. Starting with 10.023, telemetry for CSUs was enabled, and telemetry for POS events were exposed in 10.029. And yes, this means that your POS needs to be on 10.029 in order to broadcast the operational insights data. Updating your headquarters to 10.029, but leaving your POS on an older version does not give you that POS insight. In order to use operational insights, you need to create or reuse an application insights instance in your own Azure tenant. This is where all the telemetry will be sent from Dynamics 365. Now, to be clear, operational insights only broadcast event data from Microsoft managed artifacts. If you want to get telemetry data from your extensions, you will need to add code to track and broadcast the data that you feel describes the health and status of your extensions. We have some very detailed documentation on how to do this, which has been published for a few years. As a best practice, application insights is the recommended way to log event data from your extensions. We discourage legacy logging patterns, like using the Windows event log or a log file. With new frameworks and features, we also have to discuss what happens with patterns that become obsolete. One of the biggest advantages that a software as a service solution delivers is this continual innovation that we've been showing you today. We release hundreds of new features and performance enhancements every month. Some of these improvements are delivered silently with no interruption to your services. Others require an application update to realize the benefit. Rarely we come to a point where we hit a limit with a certain technology and need to abandon it for a better one. We do our best to support backwards compatibility. For example, instead of making a breaking change to a pattern or API, we release a version 2 or 3. And we will announce that the older version is now deprecated when we release those newer versions. When something is deprecated, we mean that we plan to remove it in the future. For a long period of time, at least 12 months, extensions using a deprecated pattern will continue to compile and run. However, you will get a compiler warning message. Once the deprecation period expires, those compiler warning messages will turn into errors and block that compile from completing. Since the Commerce SDK is heavily dependent on the .NET platform, we use the obsolete attribute to inform developers when patterns, classes, methods, or properties have been deprecated. Here's an example of an initialization pattern that has been deprecated. The code compiles and behaves as expected, but there is a better way to implement this pattern. If you don't know, the Commerce SDK is backwards and binary compatible with older versions. This means that you are not required to rebuild your extensions when you take an update. However, I encourage you to do so. Recompiling your extensions against the latest SDK will tell you of any of the patterns that you're using that have been deprecated. This gives you two things. One, it tells you which patterns are deprecated, and two, how to refactor your code so that it uses modern patterns. Here's another example. As I mentioned, our policy for deprecation is to give at least 12 months notice. This deprecation announcement is more than 2 years old, and these methods are soon to be removed. You'll notice that these are all related to the application insights topics that I discussed a little earlier. And in this case, this logs event data to, for example, the Windows Event Viewer or some legacy eventing tools. And you now have much better clarity through application insights that this is no longer needed. And therefore, we've announced as of 10.014, which was almost 2.5 years ago, that this is going to be deprecated and removed in version 10.033. With that, we've come to the end of this session, and we're open for questions and answers. So let's see. There is one new question sitting in the chat. If we can't use pricing engine in our extension, how do we extend it? And Srinath gave the answer here. That yes, there are examples on how to extend the pricing engine. I will discourage people from trying to extend the pricing engine only because pricing is an extremely complicated process, and it is also a very performant engine as well. That adding extensions, especially if they're poorly formed, will have a drastic impact on your price calculation. If you do need to do it, as Srinath said, there are examples on how to do it, but I often encourage people to follow different approaches before trying to do a pricing extension.
There are more questions. There are more questions coming in. So another question is like, since they have knockout in existing code, it makes easier to continue with knockout when converting the code for Commerce SDK. Looking forward, do you have any plans to completely remove knockout support? So the answer to that is the extension solution Yeah, so we can continue using that and add that as a third-party library in your extension solution. Go ahead.
One thing to mention there is that Microsoft removed your dependency on using Knockout. However, you are more than welcome to continue to use Knockout or Lodash or any of the other extensions or any of the other third-party libraries, but that is completely up to you and your development style. So this allows us to evolve our technology without imposing any of those requirements on you.
Yeah, one more question. Do we have any guidelines for migrating to our CSU core?
I'm happy to take this one. So there are two answers to this. So there is a tremendous performance improvement by migrating to CSU core. But this is more of an infrastructure change than anything else. There are no changes to API, whether you have a CSU, a regular CSU, or one that has been migrated to CSU core. All of the request response are going to be identical. So while it's a great performance improvement, there's no urgent rush to force you onto it outside of your API requests are going to perhaps execute a lot quicker. However, there is a large dependency in migrating to CSU core that we need to remove dependencies on legacy .NET objects, especially .NET 4.6, which was prevalent in a lot of our extensions before, that we need to make sure that those are no longer there. So part of the huge performance benefit is just retiring .NET libraries and third-party libraries that are 5 to 7 years old and getting us onto a more modern technology. So the best guidelines there are to stay updated, use our modern extension patterns, and try to check your library dependencies to make sure that the libraries that you're referencing are the latest and greatest ones. And that definitely will help you on your journey to CSU core. Once starting in the near future, once a CSU is completely off of legacy objects, the migration to CSU will happen automatically when a code deployment happens. So,
okay, I think that was the last question in chat.
I have a couple backup questions, or rather questions that people asked that I'm just going to re-ask on here so that they can stay in the recording. So one of the questions is, if I have a pattern that I was using in Retail SDK that is not explicitly listed as deprecated, but I cannot do it in the Commerce SDK, can I raise an extensibility request in order to use that pattern? And for that one, I'm going to say the answer is absolutely yes. Please reach out to support and submit an extensibility request or just a collaboration request to say, hey, can I do this? Our support team is amazingly well trained and well versed in all of this technology, and they will get back to you either on a pattern or a sample that we have in place to show you how to do what you want to do, or they will come back and say we do need to add this as a new extensibility request, and they will let you know what the timeline is to get that in there. So we definitely, when it comes to extensibility requests, we treat those very seriously, and we work very hard to get those to get the clarity from you on in terms of what you need to have what you need to achieve in order to deliver on that extensibility request. So Srinath, we have a question around a certificate, and let me read the question and I'll let you maybe take a swing at this one. So the question is, in the Retail SDK, I can use a simple generic certificate for Hardware Station and install this cert for multiple POSs. Now I cannot use the same cert with Commerce Hardware Station. Question is how to generate a generic cert for Commerce Hardware Station.
So for Commerce Hardware Station, you can have the server certificates that are required so that As part of the retail hardware station installation, those are required. So I'm just trying to understand the question, like you want to use a self-signed certificate or some other kind of certificate. We recommend using like the server certificates or signed certificates, which has a kind of expiration also set in those cases.
So I might go on to add a little bit more to this. I do not believe that this is necessarily a Retail SDK versus Commerce SDK issue. This is more of a, I believe, an evolving .NET requirement that we have to switch over to. I think it's TLS 1.2, and with that, it requires a higher level of certificate. It can't be a generic one. It actually needs to be a server certificate. And so for that reason, that it's more of a .NET requirement that is not inherent in the Commerce SDK itself. And with that, we are at time. I thank you everyone for joining. I'm going to turn it over to Tim to wrap up.
Thank you, Rob. I've posted a link to a short survey in the Q&A panel. We'd love to hear your feedback on today's session and hear what you'd like to see in future events. Thank you in advance for your participation. As a reminder, the recording of today's session will be made available on the TechTalks Community Dynamics page within the coming weeks. I'd like to extend a big thank you to our presenters today and to you, our audience, for joining us. We hope you have a great rest of the day ahead.